Hey, Kevin,
Yeah, Daryl.
what do you reckon about flying?
Oi, Tess! Stop bloody bouncing your sister into the coral tree! Bloody caviar. Sorry. What were you saying?
I was just talking about flying.
Oh, right. Why?
Oh, I don't know. I just think it might be really interesting to see the world from that angle.
Wait, are you saying you want to fly?
Well, maybe?
But you're an egg.
Yeah, I know, but I could wear a helmet or something.
Oi, Tess! Stop putting the bloody decorative pebbles up your nostrils! Look, Daz, I just don't think eggs are meant to fly, mate. Ow! Tess, what did I just say?
Oopsie.
Flight Simulator, where you can fly anywhere you can dream of, as long as you are not an egg. Please verify that you are not an egg.
Melanie, do you reckon I can have a go at flying your kite?
I don't know, Daryl. Isn't it illegal for eggs to fly or something?
Well, yeah, maybe. I don't know, but I wouldn't actually be flying myself. I would just be, holding your
Oi,
kite,
babes.
which is-
Is this egg bothering you? Because I'll end him if he is.
No, sorry, I was just...
Oh my god, that's like so romantic.
Melanie, your kite!
Oh, wow.
All right, Humpty Dumpty. Do you know why you're here?
I tried to fly.
You try to fly. And do you know what happens when eggs try to fly?
They have fun.
This is the third time this year you've tried something like this. What's going on, Daryl? Look, you're a good guy, Daryl. I'm gonna let you off with a warning. But this is the last time, okay? You should really get some help, mate.
Egg. A vessel for housing tiny embryonic life forms that have evolved over millions of years to live in complete symbiotic harmony with one another. But can eggs fly? Yes, I think they can.
Hello, everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host, Tina, and today with me I have some of the incredible team behind some of the latest updates to 5.4, which are phenomenal, if I may say so myself. If you couldn't tell by the title, today is going to be a bit of an overview of some of these features where we'll chat a little bit about them, go into detail, and maybe most importantly, we're also going to be answering some of your questions that you may have about them. But there's a lot to get into today, so I'm not going to take very much time for myself. First, let's get into a round of introductions so we can get everybody up to speed with who all we have with us here today. So I'm going to go just kind of in order of how we have it listed here on screen. So Ben, I'm throwing you to the wolves. You're first. Tell us a little bit about yourself.
Hi, I'm Ben Marsh. I'm a principal tools programmer here at Epic, and I've been working on developer tools for the last 10 years or so. Today I'm going to be talking a little bit about Horde, coming out in the 5.4 release.
Fantastic. Thank you so much for being here. Next up, we have Chase. Would you like to tell us a little bit about yourself as well?
Yeah, hey, I'm Chase Cooper. I'm the Senior Technical Product Manager for rigging tools and Unreal Engine. Worked at Epic for about 5 years, started out in the Fortnite team, and now I work on Control Rig and all sorts of cool deformer stuff.
Yes. A lot of which is some really exciting updates for this one. So happy that we managed to pull you over to the UE side. Next, we have Helge. Want to tell us a little bit about yourself?
Sure. My name is Helge Mate. I work in the engine team, leading the development and control rig, and sort of anything rigging animation. Yeah, same time as Chase, more or less, 5 years at Epic. And yeah, my background is in sort of films and games production before that. That's me.
Awesome. Thank you as well for being here. Next, we have Ryan. Would you mind telling us a little bit about yourself?
Sure. Hi, I'm Ryan Hummer. I'm our lead programmer running our build team here at Epic. So as Ben was first to go, I am the first team that gets to use the Horde product here and kind of gives him feedback on it. So we'll be talking about Horde today, but I've been at Epic for 3.5 years now, or 2.5 years now, leading the build team, but I've been in the game industry for about 20 years now, doing various tools engineering and build engineering along that time frame.
Fantastic. I like how you just casually drop the 20 years, no big deal, you know. Next we have Jose. Tell us a little bit about yourself.
Hey everyone, my name is Jose Villarroel. I am the lead programmer of the animation gameplay team on the Unreal Engine side. I've been at Epic since 2019. Before that, I've been watching these live streams and learning Unreal maybe since 2014, since they started and participating on game jams. I've worked on game samples such as Lyra and City Sample, and today I'm going to be talking to you about motion matching and the highly anticipated motion matching sample.
Yes, very, very excited to learn more about that one. And then last, but certainly not least, Brian, would you mind telling us a little bit about yourself as well?
I am Brian Karras. I'm a programmer on the rendering team. I'm heading up nanite development. So I'll be talking a bit about nanite and the rendering updates in 5.4.
Fantastic. All right. So obviously we have quite the crew with us here today. Very excited, like I said, to have you all here. It's going to be so exciting to talk a little bit more about some of these features. First and foremost, we're going to jump right into animation and rigging. So Chase, if I know it looks like you're trying to get stuff set up, if you want, we can start somewhere else. It's up to you. But if you're good to go.
Yeah, I'm good to go. Just had a little camera malfunction, so we're switching to the webcam.
I get it. Honestly, that was quick. That was quick thinking. I'm really impressed. Oh, yeah. All right. Well, then with that, let's go ahead. We'll start off with animation and rigging here, and I'll hand it off to you. What are we going to chat about today? Look at.
All right. So we have lots of really cool stuff in Unreal Engine 5.4 for animation and rigging. Dan, can we share my screen real quick? I'm going to pull up all the release notes that we have going. So Unreal Engine 5.4 release notes actually goes through a large chunk of everything that we've built for 5.4. So animation and rigging, all of that's in here. And I'm going to go through a lot of this today. Some really exciting features we're very excited about, like layered control rigs. This lets us basically animate on top of existing animation. and modular control rig. We're going to build a module together live on the stream really quick so people have an idea of kind of what that process is like. So why don't we go ahead and jump into some of these tools and take a look at them. I've told Helge to interrupt me as much as possible because he has lots of really cool.
I will try. See, already now. There you go.
That's his challenge for today. So yeah, let's just jump in right into the demo and start looking at some really cool stuff. Okay, so have Unreal Engine 5.4, I think 5.4.1 up actually, and we're going to go ahead and jump right into the modular rig editor. So I'm going to go ahead and build a modular rig here. Okay, we're going to rename this Rampage, MCR Rampage. My notes. Okay, so this is our new modular rigging editor, and this is an experimental feature. It's brand new to 5.4. I'm going to switch this over to tiles so we can see all our modules in tiles. And it basically lets you assemble control rigs together modularly with all these modules up here and build a new rig out of it. So we're just going to start building use Rampage here, if I can spell. Okay, Rampage. All right, so this is a Paragon character. And now that I've chosen what mesh to rig, I'm going to go ahead and hide all my bones on him. Just a little easier to see. So quick intro. I'm not going to go over every single detail because we have so many docs and stuff on this, which I'm going to talk about today too. And there's a few videos out that go into a bit more detail on this editor. But we're just going to start building his rig. All you have to do is drag and drop onto these little points. We call these sockets. This is the visual schematic. You can use Y to turn it on and off. You'll see why that's important in a minute. So let's drag and drop the spine onto the spine. All right, and we're going to drag these shoulders. We're just going to kind of work outwards on the character. All right, I'm going to grab the neck. Let's find the neck module. And you can see that the sockets kind of tell you what to place next. So as authors, module authors, you have the ability to kind of direct your rigger and how they should assemble the character and give them some guidance. So build 2 legs. Right. We're not going to build this whole guy out. Okay, so we do have a rig in there. He's really big. So we need to scale up the control. So I'm going to use Y to hide that schematic because we are done with that for the time being. And over here, we have all our modules that got built. So this is the module hierarchy. And as I come in here and select my root, I have a bunch of settings that will affect all my modules. Because it's a hierarchy, if I collapse this, I can come and change some of these settings and it should filter down through all of them. So what I want to do is actually scale all my controls up. Do that to 2. Compile. So now it's a little easier to grab my controls and come in here and animate around. It's pretty nice. We're going to do a few more things. Let's go ahead and grab our arms. We actually don't want these to be in FK by default. I'm going to change these to IK. All right, still a little embedded in there. So let's come in here and let's try to make them a little friendlier to get. All right, so now we have our IK arms that are really easy to grab. All right, so if we come over here to our rig hierarchy, a bunch of stuff happened. We have a skeleton now right here, and we also have there we go. We have our entire control stack built for us and organized. It's ready to go. You don't have to come and like add these modules and then organize this. It just does it for you. That's kind of done through the logic in control rig. And so now we have a modular rig. Just kind of test it out, make sure it's all working. All right. So we're pretty good here. Also, these leg pull vectors are pretty big. Let's go ahead and adjust those real quick. Bring those back. We're going to go look at our settings up here. So all the modules have different settings you can adjust. Some of them like this. Actually, yeah, let's do the legs. Do the spine too. This pull vector offset, we can bring this in. And you can see how our pull vectors are getting much better. So I'm just going to kind of adjust each one of these until they're kind of in the right position there. Like 0.3. There we go. A little better. Okay, and the spine, we notice that this guy is kind of high. Let's go ahead and tweak that a bit. We're here to our spine module, some settings for that. So we can come and adjust this, some body control adjustment. So I can just move this, and just pick the best place for it. Okay, so now we have this guy. Let's compile and save him. All right, we have our modular rig. This is probably good enough for us in this demo to get going. It seems to all be working. Okay,
I'll pause you there, Chase, given this is a sort of a good
Go for
point in
it.
time. So first of all, I want to point out a couple things. So you've already pointed out on the right side the rig hierarchy. That's a view that people are familiar with if they use control rig before, and that's sort of the granular view of bones and controls and spaces and other things you may have added here. On the left, the modular tree is a simplified view where you just in quotes, right, see the modules and what we call connectors and their resolvables. So you noticed as Chase was bringing the modules in that all this got filled out automatically for you. And that's because module authors can build modules in the way that they will try to automatically find the right connections for all the subsettings they have. So you see how the spine has an end bone. It says like you dropped it on sort of the hip area and it will find the last spine bone sort of heuristically that it thinks where it belongs, but users can go in and adjust this, right? So a good example for this would be if you have a tail module, something that drives like a crocodile tail, you may not want to affect the whole bone chain, but just a part of it. So, this is sort of have an initial guess that already is functional and then do adjustments after kind of workflow where you don't have to specify everything necessarily, but you just do corrections on things. So you'll bring in the module, change what you need to. In this particular case, Chase didn't have to change anything. It was just flying onto the biped skeleton immediately.
Awesome. Doing your job, Helge, interrupting me. Keep doing it. Okay, so modular rig, we've rigged this up. Also, if you're curious, if you hover over any of these modules, these are a bunch of modules we're shipping with in a plugin, and these are intended to be as an example, right? If you can use them, great. We do plan to update and add to these as we go on, but the idea is that these are also, primarily a learning example for riggers and teams to figure out how to author modules themselves. So let's jump into Sequencer a little bit. So I'm going to take my modular rig here. I'm just going to drag him into my level. Okay, let's go ahead and focus the camera on him a bit. It's all working, looks good. So one thing I want to talk about with our new animation features is that we have completely rewritten the Gizmo framework for animating an engine. So you can see we have a much nicer design here, improved look and style, and a lot of other features like indirect. If I go to my rotate and I come way out here and I hold down the middle mouse, I can rotate. So this is way nicer for animation and posing characters. And it works on all the gizmos too. I can just indirectly grab this, and pretty nice. The other thing I want to mention, it hasn't been mentioned too much, is we have a parent space. So we have a world, local, and we also have a parent space now. So this is useful in very specific situations. I'm going to keep this in local for the time being. Okay, so let's do a few things here. I'm going to go ahead and twist this guy. And if you notice that as I turn this control, we're having a phenomenon, what I usually call candy wrapping. And so as I keep twisting this, his wrist is clearly broken. It looks not great. We don't want it to look like that. We really want it to work more like a regular forearm. It's not too bad when I do this, but it's just clearly not looking great. So we're going to spend the next few minutes trying to correct this. And the other thing we're going to add is, if you notice the muscles, let's see here. This guy has some pretty big biceps and triceps. They're not really doing anything. It doesn't really look like they're part of the character, but we do have some bones in there that we can kind of fix him up. So we're going to fix up these two areas right in the engine. And I'm going to start by creating some animation. So let's do a little animation on him. I'm going to twist this guy, and we're going to go to frame 30. Be quick. All right, make sure we're seeing that really gnarly candy wrapping happening. Okay, and let's go back to here, and let's zero this out. And as you notice, as I'm setting all these keys, that we've rewritten the anim details panel inside the animation mode to be much more friendlier. And so what it lets you do is, if you bring up the curve editor, I love this feature. This is really cool. You can isolate your curves really easily. So if I just animated the rotate X, I can just come in here, click on it, and I get the curve immediately. If I wanted to go and change another curve, and you don't have to, while coming through here is fine, this is just a really quick way to get to your curves and animate. Okay, so I'm going to set up a few more keys here. We're just going to bring it up here, just kind of, and just to be able to test this, a little calisthenic as we go down this next part of the demo. Like that. This type of pose is usually pretty gnarly on characters. Just the shoulders don't really usually maintain volume very well, and a lot of extra steps, sometimes like pose drivers, usually have to be made to fix that. Okay, so we want to save our sequence. Okay, so let's go, and we're going to actually make a little module to fix this. So to build a new module in modular control rig, it's fairly straightforward. We're going to create a new control rig, not a modular rig. Very important. So you're going to get this dialog. You want to select control rig, right? And so as I have my new control rig here, we're going to name this constraint. Okay, and you want to name that whatever you want your module to be. And we're going to hop into control rig. Go ahead and dock it up here. Okay, so now we're in the control rig editor. And this is an empty control rig, so we need to import a template. If you have our modular plugin loaded, there's some predefined templates. You can just type in template, and we have a chain, a biped, and this root template. That's just like one bone and a pelvis, I think. But this usually works for most things. You can just bring in the biped, and it's an empty skeleton. I'll turn on all the bones. This is a very lightweight asset with, I think there's one triangle collapsed to the bottom, basically simulating an empty, as small as possible skeleton. You want your templates to be, whatever you're building your modules on, to be very small and lightweight, because all your modules are going to reference them. So that's what we provided here, is a way to just quickly have something to start building modules on.
Just to clarify, you can use any skeletal mesh, right? You don't have to use the templates. Right. The templates, we ship them because they're lightweight and they're empty skeletons. But let's say you're building modules purpose-built for 2 specific characters on your show, and you have the skeletal meshes. Of course, you can use that as well to preview the module you're building. You don't have to use the empty template. Yeah.
So this constraint module, what we're going to do is basically build one node to expose here. So all the modules, before I keep going, all the modules we have in modular control rig, yes, these define like parts of a character. These are pretty beefy rigs, right? A shoulder, spine. There's a lot of rigging in here, but all these modules, new modules, don't have to be this big. They can be utilities too. And that's the really powerful part of this framework, is that you can really quickly mock stuff up and then add it into the system and have it even work with all these other modules. So that's what we're going to do here. We're basically going to expose this parent constraint. The first thing we actually have to do, actually, let's delete this first. We need to turn it into a module. I forgot that step. We have a button up here, switch to rig module. I'm just going to click that. And a couple of things happen. You get some directions down here to help you out. But all of our bones turned yellow. That means they are now being procedurally imported. So that's a real important note, that this is now a procedurally generated control rig in full. So this is a module. We're going to save it. Just to double check, we can see right in our modular rig, we now have access to this module in the editor. Okay, so a few other things we might want to do. You might notice there's no icon. Let's come back to control rig, go to class settings, rig module hierarchy. We have a bunch of settings you can set up for your module, such as the name. It'll automatically name it to whatever the name of that is, but you can also change that here. But we can also set an icon. So you can build your own icon. It's pretty straightforward, but we also, in the plugin, ship a set of a bunch of icons that you can use for your modules. Some extra ones that aren't actually in the included one. I like this guy. This kind of represents a constraint. So let's do this really quick and give it a second. Okay, so now we have a new module constraint popping up. So let's go ahead and start building out our logic. So parent constraint, we're going to go ahead and hook this into our forward solve. Okay, so now we need to figure out a way to have our module talk to this node. So how we do that is with connectors. We're in modular control rig. We have all these connectors. We need to build these inside of our module. So that when you convert a module, you get one primary connector. This has to exist. You shouldn't delete it. I'm just going to drag this to some random bone. It's okay. And we're going to actually rename this. There we go. Click on it. And I like to call these constraint. I always call the primary module the name of the primary connector, the name of my module, just for sanity. And you'll notice over here, if you come over to the details, connectors have a few attributes we can set. We have our type. You can't change the primary, obviously. And then we have some rules. So what you want to do, you can set up all sorts of type of rules in logic for how these connectors resolve. So I like to set the primary connector to be rule of type socket. Okay, so I'm going to set that to type socket. And so now what that's going to let me do, without doing anything else, it's going to give me that drag and drop functionality that a lot of people like. So we're going to actually, let's do the wrist first. So to create a new socket in here by hand, right, click on any bone, new socket. Okay, now we have a interface in the schematic that we can interface with. Now I can just drag and drop straight onto there. Actually not going to do it because it doesn't do anything yet. So, but now I've confirmed I have that drag and drop interface that the rest of these modules follow. Okay, so we're going to build a few more connectors. I'm just going to randomly pick, for this module, it doesn't matter where these are necessarily. I'm going to pick new connector, and these are secondary connectors, denoted by the little 2 icon. And we're going to very simply call these A and B. Okay, A and B. And you can come over here to their options and it says secondary. We can also make these optional. We don't want to do that on these because we want these to be required. If you make these optional, the connector doesn't need to be resolved for the rig to build. That's great for like optional, maybe you want to give the controls a parent in your module. But maybe it's not required and you don't need to have it in theory. That's where you would use optional. And we're going to change their type. We're actually going to just delete the type on these because we want these to be able to resolve to many different kinds of elements, such as nulls, bones, controls. And we're going to do that. Okay, so now we need to get to this data in the graph. How do you do that? I'm going to bring up the get connection node. So this get connection node lets you access these connectors. You can see type connector, and I can then pick my connectors. So I'm going to pick my primary, my constraint here. And I always check on skip socket. This will basically, if this does resolve to a socket node on the schematic, it'll just give you the bone back. You can always just check that on if you're unsure or what's going on. I would recommend checking that on. It's pretty harmless. So we want this bone to actually be constrained by these 2 guys. So I'm just going to copy that down here. And I'm going to choose A. Then I'm going to copy this again. I'm going to choose B. And in this parent constraint, we're going to have it wait between these 2 nulls. So I'm going to do this, and we're going to give the weight. We're just going to split it halfway. Okay, so this is all we have. And now what should happen if I drag and drop this constraint node onto my forearm here? Let's see what happens when I rotate. Let's turn off the schematic with Y. All right, we have to resolve this. Sorry. So I've added that. That's there. Now the module is down here in our module hierarchy. Let's make this a little bigger so it's easier to see. We need to parent the module, just like you do with bones and controls. We need to parent this to an arm. So here we go. I try to think of the parenting as like, what space is it in? This kind of lives in the arm area, so you want to parent this to the arm. That's the best way to think about it. And we need to tell A and B, what do we want to constrain it to? So A would be your wrist. B would be your elbow. All right, so now once we do that, now we're getting a really nice twist. We have a few other problems we're going to work out, but it's actually not a problem. But now that twist is way better. It's not just candy wrapping and breaking that wrist. But something we do see and we don't want is breaking it in another way. That constraint is fully active. So you can see that bone is really turning. And actually, if I turn off the bones, it's probably a bit easier to see. Right? We just want this rotation. So we're going to expose...
I'll stop you. I'll stop you right there, Chase, even though your flow is great. I just want to highlight a couple things here, right?
Okay.
It may be obvious to the viewer, but just making sure. So the way that the modules connect to the hierarchy at hand, like how they connect to Rampage here, is that you create these connectors, and the connectors become sort of placeholders, right, for what you're really affecting when you apply the modules. So if you go back to the constraint view, you sort of see it. I don't know if you can zoom in, but it will say on the connector name, it says connector A on those nodes. If you zoom in on one of the get connection nodes, it says A and then spine 3 and spine 4 in braces, and that sort of means that A is really spine 3, right? And B is really spine 4. It means in this particular preview view, it's resolved to these bones. Once you're applying it to Rampage, it will have resolved to something else, which is whatever you picked and how you filled these up, right? So basically what we're trying here is that these get connection nodes, they really give you access to what the user has chosen on the character. So if you have multiple instances of this module on your rig, like each one will have a slightly different resolval pattern here. And also the other thing that you mentioned, I would just want to get back to it, that each connector can have these rules to say this connector can only connect to a control, or this connector can only connect to something that has a tag X, right? And the idea here is that you can either work with lots of rules or you don't, and it really depends on your pipeline. If you want modules that work really with strict rules with each other, so they can only be used in certain cases, then you set up the rules that way. You don't have to, though. You can make them freeform and connect to anything. Like in this example, the constraint can basically connect A and B to anything. I just want to highlight that that's a feature that you don't have to come up with really complex rules if you don't want to, but you can constrain the workflow using these quite a bit to fit your pipeline needs.
Yeah, and it's very flexible. That was something we were talking about earlier too. It was how to present this, and we have a framework here that is flexible, and these modules can be designed in a myriad of ways. While the ones we're shipping are very drag and drop and stuff, there's a lot of ways you can actually author and work with this system, depending on your problem set or whatever characters you have in your real-time project. So what I'm going to do is show a few more features of this because it's pretty powerful stuff. So we want to fix that. So you can expose any data you want to the top level of the module. And we're going to expose this filter in the parent constraint. This is basically telling me what axes I want to work, because we want to get rid of that gnarly wrist breaking thing. So I'm just going to take this filter, promote it to a variable. All right, let's make this a little bigger so it's easier to see. Okay, so we have a variable down here. And I'm just going to call it filter. And it is not public yet. This little eyeball over here to the far right, if I click that, now what's going to happen, save it, come back to my modular rig, select my constraint. Now it's exposed to this top level inside of here. So this is a really powerful feature. You can expose just about anything you want in that manner. So now what I can do is I can uncheck what I don't want to have happen. A small bug. Okay, uncheck all of this. Okay, let's do this guy. All right. So now I just unchecked. I only want the rotation of the X to be affected. So now we're not getting breakage anymore. When I twist my elbow, I'm getting a really nice, now it's doing exactly what I want. If I come up here, it's just much better forearm twist, not breaking anymore. So some other things you can do, you can keep exposing these data if you want. So you can expose like the weight for instance. So let's make it a float weight. Let's go ahead and make that public. And then we're going to plug this into a subtract node. It's a little trick I like to use. We're just going to minus it and invert this other value. So now this is balancing itself. You don't have to manage each weight. So if I come back to here, maybe I want to have this this weight favor, let's see, scale thing again, favor the forearm more. So now it's going to favor the wrist a bit more, or the elbow, depending on how I tweak that. And you can get kind of some different effects that way. And that's just one attribute on the constraint. I mean, you can keep going to town and expose. Yeah, so see if I crank it down, now it's favoring the elbow a lot more. This is probably like something there. There we go.
A couple things to highlight here. Again, I'll go quick. Is
Really?
First of all, one of the things that I'm quite excited about is, and it's sort of, I guess, something you'd expect from Unreal, is that everything's always live. So as you're changing these, the character that they operate on, they get the update immediately. And actually, as changing is setting the settings, for example, on the filter, the rig gets rebuilt all the time. So you can't see it, but it's actually rebuilding the whole character rig all the time as he's changing his settings, so that you get a live preview of what the results would be. Right, so that's really exciting if you compare this to workflows in classical DCCs, where the notion of rig building scripts exists, but you tend to have to wait a couple of minutes until the character is built and then see if it works and go back. This is now sort of what you see is what you get kind of workflow and with immediate results.
Yeah, here I'm in sequencer, and you can just see all those changes I did are instantly flown through into the level editor. You don't have to wait or do anything else. You just compile and it's there immediately. So really good workflow. I can't do it because we're on a live stream, but you can have up a couple screens and see all this stuff happening live. So it's a really great workflow for like testing out how your rig is actually interfacing or on certain animations. If you have a bunch of animations. How are we doing on time, Tina? Are we doing okay?
Yeah, you're doing great.
Okay. So the next thing I wanted to do is show kind of how this constraint, while I'm using it on the forum here, you can actually use it for a myriad of things. I could keep going on this. We're going to keep this fairly simple. I think this is fairly straightforward. But even this is like really powerful for a couple of things. So let's turn back on our bones. And we're going to add some sockets to our muscles up here. So he has a lot of big creaturey muscles. So two new sockets. Hit Y to turn on our schematic. Okay, so now I have two new sockets that I can add constraints to. So let's start with the bicep. Let's actually save that guy. Save this really quick. Okay, I'm gonna drag this over here. Okay, so just like we did with the forearm twist, I'm going to drag and drop this under the arm. Okay, and there is an evaluation order in here. Let me set this up real quick, then we'll talk. Maybe Helge can talk a bit about evaluation order.
Sure. So as you set it up, so basically that as Chase is parenting these together in a tree, that there's two reasons for the tree actually. One is sort of just organizational, because it makes sense to have things that belong to the arm under the arm. But it's also currently in 5.4, it's the only way to indicate execution order. So the arm will run to solve the arm, and then these two constraint rigs like modules will run after, right? So the tree is also a way of telling the system which order things should be evaluating.
Yeah, so now just setting up and resolving those two connectors, I get kind of a very cheap like muscle preservation. You can see the biceps moving a little bit more, and he's just a little more alive. And this is just one constraint bounce between two nodes, essentially. So you can do some interesting things in here. Here's a little bonus tip. You can do things like, debugging. So this is fun. Let's draw a line. Okay, so I'm going to get my, because these are the bones, let's get the transform. I wasn't going to do this demo, but I can't resist. So, because this is a really fun way to do interface with
Well,
this.
we've got you here. May as well, right?
Okay, so now we have a line. Let's give its thickness a bit bigger. That's good. All right, so now I've added this line. You can see it's going to draw a line between my A and B connectors wherever they're resolved to. So now you can see I have there's two lines here because I have two of these in my scene, but now I've just created a quick debugging interface. So this is telling me basically that this bicep is balanced between these two nodes, essentially. So some really interesting, I mean, you could have a whole module that just runs a bunch of debugging operations, or you can write these in. You can set up a bunch of settings, essentially, to, if you don't want to see that stuff all the time, we'll just create a branch node. And if this is on, we'll do our same little thing here. Let's call it debug. And we're going to make this public. Right. So now we come back to our modular rig, and those are off. But maybe I only want to turn it on for this guy, so I can turn on debug. So now I only get it for that guy. So very quick, this becomes a tool that's much more useful for a myriad of different things. All right. So let's go ahead. Here, we'll do go ahead and do the tricep too. I'll do this one more time so you can see how this is set up. Really fast, we'll come in here. And for the tricep, turn off that schematic. This guy has a lot of bones. Sometimes it's easier to work in the lighting only mode. Oh, yeah, it's a little more familiar for me. Let's go ahead and pick this guy. Plug that into A. And plug the elbow into B. Right, so now we should have a bit of movement happening there. Great, so now we have a cool little like cheap muscle setup. Let's look at our lit. Let's turn off our bones. None. All right. So he's just a little more alive, just with a little bit of rigging in here, and with a module now that's useful in a lot of different types of things now. It's not just, handling our forearm, handling some muscle movement up here. I don't love that twist happening when I do that. We'll fix that, but it's more so to demonstrate what's happening.
It's something to stress as well, right? Is that yes, you've just built this as you were setting up Rampage, and it seems like it's purpose built for Rampage, but it's not, right? You build a tool that you can use in all the characters, and the more parameters you add to, the more applicable you make it to different scenarios as it possibly historically grows as you work with it. You rarely have to go back to the graph ever to set up a constraint constraint module if you have a good set for your production. So I just want to stress that yes, you're doing it incredibly well in this fast demo. Usually you do this like a couple times in production, then you just keep using the modules, right?
Yeah, and I also want to note too, everything I'm going over today, I have we have released the modular control rig documentation. This is all documented in how to write a module. So I put the QR code here. You can come in here and browse through and see kind of all the modular rigging. If you're curious about creating your own modules, there's a lot of info in here. So you grab this QR code and it'll take you straight to this docs, which are now on the EDC. Super great. So real quick, let's talk about, let's hide this guy. let's talk about a few of our other tools. How much time do I have, Tina? Do you?
I mean, how much do you want to go through? I'd say probably if you have something for the next 5-10 minutes, that's probably fine.
Great. Yep. We can do this in 5 minutes. Okay. So if you notice here that my wrist is still candy wrapping a bit, we can take this a bit further using some of our other tools. So I'm going to create a new deformer graph. All right. So the deformer graph is in beta currently, and we'll just keep it deformer graph. It's fine. And it basically lets you add real-time deformers onto your assets. So I'm just going to step through here. I'm going to come in here. I'm going to add Rampage as my mesh. I'm not going to get too in-depth to this editor. I just kind of want to give you an idea of what you can do with this. It's really powerful. In 5.4, we're shipping a suite of deformers for your characters. So we're going to come in here. I'm going to start building this graph out. So we're going to do our skinned mesh. Let's do that. Okay. All right, and so I'm going to build a little, what I call deformer stack. Okay, so we start here at our points, our skeletal mesh, and we're going to go down the stack. And we're going to want to query linear blend skin. That's what we see now. I'm going to come down here and I'm going to do a compute normals tangents because we want to have that happen again, and then right end of mesh. Okay, so right now, this is basically just defining a very standard deformation stack for this guy. This is what we're seeing in the viewport. When we're in here, this is kind of the idea. So what we're going to do is swap this out for a dual quaternion skinning method. And what dual quaternion skinning does is it will maintain volume in specific areas very well. And the wrist is one of those. It really works well in the wrist and elbows and like shoulder regions. So we have a suite of deformers shipping with 5.4, and and dual quaternion skinning is one of them. So I'm going to pop it in here, just right under here, and I'm just going to connect this up. Okay. And so we're going to load a bit. Actually, let's go here. Let's export out our animation. So I'm going to bake out this animation sequence so I can access this later. Rampage. All right. Cool. So now I can come in here and I can load up some animation. There's our Rampage animation. So now we see that in here. And you can see that we're getting some candy wrapping. But not as bad as we were. So if we compare this to the linear blend skin, we compile, you can see just how much more volume it adds. It's kind of subtle in this instance because we did help it with rigging, but it's enough. It like does make a pretty big difference. And just everything looks generally, you're maintaining volume a lot better, especially like in the shoulders and the elbow regions. Let's go ahead and take a look at that again. We'll compile. All right, so if we wanted to leave it here, we could actually plug this in. And how you hook this up and to see it in here is we need to find our skeletal mesh in the level. And you can come down in here and we search for our deformer, turn on mesh deformer. And let's see, is that the one we want? Yes. All right, so now those updates are flowing through into the level. Now we're getting a much better rotation in here. If I come in here and let's go to that. Grab it. All right. All right, so that's the deformer graph. We have a whole suite of deformers, linear deformers, such as twist, and there's some videos out there right now that kind of show some of this stuff in action. Really cool. And Daryl went over that in the 5.4 features overview too, which is really awesome. Also, real quick, we're not going to do a ton here, but we have updated the skeletal editor a bit. I'm just going to go over the release notes on this just due to time. Sorry. So in our release notes, we go over everything I went over today, plus a little more. And we have, let's see, skeletal editor. Skeletal editor is moving to beta. So it's all about components. So coming in and cleaning up your weights, adding animation to it. That's all in here. And a few more cool little nifty control rig features. Helge, feel free to jump in on this one as direct manipulation. You can now select certain nodes inside of control rig and interface with them visually. We're calling that this direct manipulation. Right, and last but not least, retargeting. I gotta show retargeting because it's just so great. And we'll call it a day. Okay, so the new retargeter has had a ton of work. It's just so easy. You right-click on any animation sequence, and you come into retarget animations, and we're going to pick Rampage here. That spell. All right, and so then you can come through here and pick whatever you want to retarget. You can see he's getting retargeted immediately. It's looking pretty tough in this one. And to export, you just export your retargeted animation. Just click through this. All right, and so now we have a new animation retargeting. That's how easy it is. A lot of info online docs, but I don't want to go into it too much more because that was the big point of this release, was simplifying that greatly.
Well
Right,
done.
so
I didn't have to interrupt anymore, so very well done.
Wonderful. Like I said, check out the release notes. We have a lot of other cool things in here with more details, and there's some other videos out there kind of going into detail on all this stuff a bit more.
Yeah, we'll be sticking around, so if you have questions later at the end of the stream, feel free. I'll be here as well. So if you have technical questions, anything like that on control rig in general or modular rigging specifically, let us know.
Fantastic. Awesome. I'm glad that you did do the little bit on retargeting, because I loved watching just a slew immediately as soon as you did it go, oh my god. I know it is exciting, everyone. Awesome. All right. Well, thank you so much for walking through that. Like you said, there's so many updates. So obviously, yeah, please take the time to go read through some of the release notes to get a little bit more information on some of that stuff. But thank you both for walking through that. Really appreciate it. We're taking questions still from chat, obviously, as this all goes through. So if you have questions on any of the topics as we go through, just toss them in there. We'll grab them, and at the very end, we'll do a Q&A segment. So if you got anything you want to ask, make sure you put it in there. That's the whole point of this. Next up, I think, Jose, if you're up for it, we'll hand it over to you to chat a little bit about motion matching.
Yeah, sure. I'm ready.
All right, let's do it. I'm ready.
Okay, everyone. So today I'm going to be talking to you about motion matching, but also what I'll be showcasing motion matching on is the motion matching sample that we will release in June. So there you go. That's when the sample is coming. If you could screen share my screen now.
There we go. We've got it pulled up for you.
Awesome. All right. So this right here is the motion matching sample, which we've officially titled the game animation sample. Everything that you see here is obviously still work in progress. We're still not done. And along with this sample project, we're going to release an example on how we do motion matching internally, how we realistically use it in a game scenario. And that's why we're calling it the game animation sample. The intended purpose of this sample is that over time, we're going to upgrade it and update it and so on and so on. So 5.4 may have something, the next release may have something else, the next release may have something else, and so on. So let's start off by telling you a little bit about what motion matching is. If you see this line at the bottom, this is the query. This is what the game wants the player to do. So motion matching is an animation technique where we select the best possible animation from a motion matching database, and that animation is decided based on things like the character's intended trajectory and the character's current, future, and past poses. Those we call features, and those are what are used in the motion matching search. So we search the motion matching database for the best matching feature, and that chooses what animation you're going to pick. In this example here, we have a full on-ground character locomotion. And the two main problems that we wanted to tackle here is a strafing movement set where the character is always facing towards the camera, and a forward-facing animation set where a character is looking in the direction of the movement. We also wanted to include some other examples of things that you can do with motion matching, such as traversal, that you're going to see right here. And jumping, landing, and all that good stuff. So let's talk about the minimal setup first. I'm going to bring that onto my screen right now. So this right here is the minimal motion matching setup. So this is all that you need. Like this part over here is optional. I just kept it because it worked for my example, but let me just remove that right here. So you drop a motion matching node, you drop a pose history node, and you connect that to your output pose. And check this box right here that says generate trajectory. And there you go. Your anim blueprint is done. Now let's go over to your database selection. Over here, I prepared a database, but so that you see that I am not lying. Right here, you see it, it's empty. So let me just replace what animation blueprint my character is going to have right now. And there we go, beautiful animation, T-pose character. And now let's bring in another asset. All right, so right here, I pre-prepared just a folder full of animations that I thought worked well with a drag and drop. So right here is my motion matching database, which you can just drag and drop your animations on. And there you go. I dropped all of these animations in. In the post search database, you can just see this is my coverage. These are the animations that I have. And now I can just run around and play those animations. So one thing that I really like that has been going on with the community right now is that the community is sort of speed running of who can have the fastest motion matching setup. And I think I've seen motion matching in 12 minutes, motion matching in 10 minutes, motion matching in 5 minutes. So this is the speed run over how you get motion matching set up in your product. There is one asset missing right here, which is the schema. So a schema is another asset that describes, when I mentioned before, motion matching matches features or channels. The schema represents what those channels are and what are the things that you care about when you select your animation. For purposes of not breaking my demo here, I prepared another asset here. When you create your schema, you get just this. Under skeletons, you can select which skeleton your schema is going to be used for. In this case, it's just my character skeleton. And then over here on the channel section, you can add channels. So I'm going to start with four channels, and I'm going to describe a little bit over what they are. The most common channels that we use are three. They're the trajectory channel, and there's the velocity channel, and then there's the position channel right here. So the trajectory channel means exactly what you're seeing right here. This is my character's trajectory. And I'll actually use another debug draw here to show this. This is the game trajectory. So this is what the character is doing. And the trajectory channel lets you specify what do you care about the character's trajectory. So over here, you can add samples. I added 4. And I believe these ones are auto-populated for you the first time you create it. And these right here are where you see offset right here. This represents the time in the trajectory that you care about. So I care about where my character was 0.4 seconds ago. I care where the character is right now. I care where my character is 0.35 seconds in the future. And I care about where my character is 0.7 seconds into the future. That's the trajectory channel. The weights over here represent how important are these channels to your overall search. Motion matching will sort of like quantify the values over all of these features, like your trajectory or pose, and it's gonna score them. Then it's gonna weight them based on the weight that you have on your database, on your schema, and then it's gonna add up all those scores and give you the one with the lowest score, which is the closest to your current animation. So trajectory channel, then there's the velocity channel, in which we can specify, okay, we care about the trajectory of the character. Now let's talk a little bit about the pose. Let's say I care where the foot is going to be, or what the velocity of the foot is going to be. You just pick, I care about the velocity of the feet. You can do the same for the other foot. And did I do the same thing? Yeah, okay, different feet. And then the position channel, it's the same thing. Maybe I don't care about the velocity of the feet in the future. I care about where the feet are going to be in space in the future. You can use the position channel. But it works the same way. You can just specify which one you care about. But for this demo, I'm not going to use it. And then let's go back to our PostSearch database. In your PostSearch database, you can specify what's the schema that you're going to be using, which features you care about. And just going to put that one here. That's it. There we go. And now let's talk a little bit about how you can make sense out of this. So I'm going to run around a little bit and use Rewind Debugger. Rewind Debugger is a tool that has been out for a while that lets you debug everything animation related. So I'll just run around with the character. Pause. And now I can see exactly what the character was doing. And now this is going to be your best friend if you're working with motion matching, and that is the PostSearch debugger. It's lots of numbers. It's very scary when you first look at it. But in reality, you only care about a few things here. And that is, I clicked that by accident. Sorry. Open that. What you care about here is the cost. So if you look over here in the asset, you can see which animation at the top is the animation that is selected. So it's a run start, and it becomes different animations as I move around. Then the next thing that you care about is the continuing pose. This means this is the next animation that this is the next frame of animation that the character would naturally transition to. And then you have pose candidates, which is everything else. So what you'll see right here is, well, exactly this. We're sorting them from least cost to most cost. So these ones are sort of likely to get picked. This one was the best pick, but as you scroll down, you can see that the number grows bigger and bigger. You're never going to pick those animations. So let's talk about what the continuing pose is. The continuing pose is the next natural animation. So if you have an animation of running around, your next frame is going to be your continuing pose. Generally, when you use motion matching, and even outside of motion matching, you prefer to go to the next animation unless there's to the next frame of animation unless there's a reason to change. For that reason, we use something that is called the continuing pose bias. And I've lost my assets. I don't know where they went. It's right here. Okay. We use the continuum pose bias. This means how much we bias our scoring. It's literally an addition to the formula that calculates that cost. That says, okay, give this animation, this frame of animation, a little bit of a lower cost. So we prefer always going to the next animation. And that's pretty much the basics of what gets your character to keep playing the same animation while you're running forward. Now, in your Rewind Debugger, which I've lost again.
It's easy with all these windows open. They just hide.
Yep. I usually work with multi-monitor, so it's a little bit harder when you don't have that in a live stream.
We have you on hard mode. Yeah, for sure.
So let me just rewind back over here. Okay. So right here, you can see a breakdown of the features that we define in our schema. That's trajectory, right foot, left foot. And you can just see how much each one of these impacts a decision. So if we go to the exact frame where we switched from one animation to the other, and that's pretty easy to see in Rewind Debugger, you can see the weights of all of your animations. Just find the very first frame. And you'll see as I go back and forth, I changed animations right here. So let's see. Why did I switch to this animation? It's because this one was the one with the lowest cost. And in the frame of swap, which is, I'm a little bit confused. Where did the animations change? Right here. So you can see that the continuing pose would have been continuing the run start. And then the next frame, my continuing pose was exactly that animation, the animation that I would have picked if I would have continued the previous animation, but another animation scored better. Now, I mentioned before, that you see a lot of these animations here, and that part is scary. If you only care about seeing what's the best score of each of an individual animation, so these are one animation that has 30 frames will have 30 entries in the same animation. So if you only care about the best entry for one particular animation, you say only best pose asset here, and you can see, oh, I only had these many candidates, and those are all that I searched. And this is a lot more digestible over what it is. So now that we've covered the basics of motion matching, this is what's going to get you 80 or 90% of the way there. This is what those 5-minute, 10-minute videos tell you what to do. But there's always things that don't work quite right. And the purpose of this sample here is we want to show you how to get that final 10% done. So let me revert back to my previous animation blueprint, and I will show you that right now. This is the animation blueprint that we're using in the game animation sample. It is a bit more complex, but that's because it's a lot more robust. This covers a lot more of all the cases. This is the setup that will work in your game, drag and drop. The main differences here is that motion matching is an excellent tool for picking animations from a database, but motion matching can also get confused, especially when you have low coverage. Low coverage means what happens if I'm going at 30 degrees, or if I'm going half as fast as my animations were authored. What happens if I am if I don't have an animation that matches that exact? And that's why we use this function that you'll see right here, evaluate chooser. So choosers are a feature that's also not new in 5.4. There's some additions that we put in 5.4. But generally, the idea here is we don't want to confuse motion matching. So we've isolated in our official setup starts, stops, pivots in separate databases. That keeps our selection clean, and it means if I'm starting to move, I only search my starts. If I'm stopping, I only search my stops, and same with the loops. And choosers have a pretty robust integration with Rewind Debugger 2. So if I click record right here and I move around, now let me just go back here. You can see right here live how my selection changes and what chooser gives us. And choosers, you can use this to choose from any character blueprint values that you have in any blueprint. So in this case, it's just these 4 over here that we computed manually somewhere in our event graph of our animation blueprint. Choosers will give you one database or multiple databases that you search. Those run through this function right here, evaluate chooser, and we call set databases to search on an animnode function. If you want to learn more about what animnode functions are, that's available in the documentation, and we're gonna be very detailed in our sample when we release it. For now, just look for animnode functions and you'll see how this works. But basically, set databases to search tells this node right here, these are the databases that you want to search on. And now, let's talk about something that you're not going to find most likely anywhere right now. So let's talk about traversal. I know a lot of people are probably wondering, how do I get this to work with motion matching? And I'll tell you right now. Our traversal actions are montages. You play montages, those montages have root motion, and it is actually pretty straightforward. What you do is this right here. You have the motion match function, which you can give a set of animations to search. These animations can be from chooser, or it can be a whole database. It's really up to you what you give to it. And then you just say play montage with the result of that animation. And that's really the architecture of how we've done all of our traversal in this sample right here. So let's look at a little bit of that right now. By the way, how am I on time right now?
You're doing great.
Okay.
You got plenty.
Okay, awesome. Let me do a traversal action right here, and we're going to debug this. So you see right here, when we start when I press spacebar to do our first frame of that traversal interaction, we are running a search on just that given frame, and the search is returning to us the best animation, and the best frame for that animation to start on. If you see right here, I was showing before on Rewind Debugger, you could see the trajectory and other things. Here you'll notice this point that represents the edge of the geometry. You can get this from any calculation that you do on your game site. This can be a trace, this can be a predefined warp point. That's all really up to your own game project. But we want to feed that position directly to our motion matching search. So I'll show you how to do that right now. What you want to do is to create a custom channel. You can do that by going to Blueprint, all your classes, select for channel, and you can pick position velocity. It's a position, it's the position of the edge of that object in the world. So I created it right there. And this will give you one function to override, which is this get world position. So I've already made this one over here, in which I fed that world position through an interface. So all that I'm really doing is feeding the result of that trace over to motion matching. And then in my post-search schema, when I am choosing one of these features over here, I can select exactly that type of channel that I created right there. So this PSC, or this new blueprint that I created, it's right there. You can just pick that one. It will just work. And to feed that value to your through your interface, you can choose how you're feeding that. Since I used an interface, as you saw in that blueprint, I'm just feeding directly the result of my trace over to the search. You just run the search and you're done. And now I wanted to talk about 2 more things. One is a lot of the samples that we've released in the past have been very strafe heavy, like a strafe shooter, kind of like Fortnite or Lyra. We also want motion matching to have a good example of how you use it in a forward-facing situation like this one, where you have the nice directional starts with nice looking rotations. For that, we've created a new node that's experimental in 5.4 that we rely for all those kinds of transitions. That is called a steering node, which is this node right here. So if I have, do I have something like 5 to 10 more minutes?
Yeah, absolutely.
Awesome. Okay, so if you're familiar with motion matching, you're familiar with the motion matching node. Motion matching node selects your animations, then blends over them using something called a blend stack, where we choose an animation, then we choose the next one, we blend to it, we choose the next one, we blend to it too. A blend stack, if we select 2 different animations, like for example, left animation blending with right animation, we have animations that are going in different directions. If you've used our post-warping nodes like orientation warping, this one right here, these ones rely on root motion information to tell you how you need to warp your character animation. So if I have an animation that's authored to go forward and I go at an angle, I can warp that animation using orientation warping. Now, the problem here is if you're operating on the blended result of both animations, where one is going left and one is going right, the root motion just makes no sense anymore. The root motion result is nowhere, it's 0. So the way you want to solve this problem is by warping each one of those animations individually. So this is what a blend stack or the motion matching node looks like internally. You select an animation, you blend to the next animation, you blend to the next animation, and each one of these selections of animation can have an internal graph, just like a state machine does. And that is the motion matching blend stack graph. You double click the motion matching node and you get it right here. And this means that any operations that you do onto your animation, onto the pose, they will only affect that one animation and then blend the result of all those graph run animations together. So we can run animation orientation warping on each one of those animations, and we can run steering. What steering does is it grabs the root motion information from the source animation and it warps it towards our character's desired facing. This one, the desired facing, you can calculate it in any way that you want. We did it using our trajectory. We looked at the future of the trajectory, so 0.4 seconds into the future. That's where our character is going to be. That's where we want to warp our animation towards. So we run steering that warps the animation, and then this other new node, this has been experimental since 5.2 or 5.3, but we've used it in this sample, is the offset root bone, which grabs the root motion information that's a result of all the graph that came before, and we apply it as an offset to the root bone. What is the result of this? What this means is, let me just disable the offset root bone for a second. Our character is doing this. Our character is snapping, 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 snapping. Offset root bone. Our character is using root motion information from the animation to drive the rotation of the character. And that lets us have nice directional motions. Now, that's it for motion matching. There's a lot more that you can learn from community tutorials. I promise our official documentation is coming soon. And when you have that, you're gonna be able to see all the small features and details and things that you can do with motion matching. But what I wanna share with you now is, I was following chat a little bit, and some people mentioned like bringing animations to my character is extremely hard. And that is a problem that every single project runs into, both like from the community and even internally. So what we wanted to do here is to sort of make this the hub of, you want to use your own character's animations from samples that we've released, or you want to bring your own animations to another character that you have. We're using live retargeting to retarget this motion matching set to any character, and this sample will include examples of how to do that. So as you see right here, this is the UEFN mannequin. This is our UE mannequin. We have Echo from Valley the Ancient. We have a metahuman. And everything that we do here is compatible. And you can also see how high quality your retarget is across your different characters. So when the game animation sample comes up, you'll be able to have examples of how to bring animations to your own games, use motion matching with your own characters, and even share animations across different projects that you may have or with samples from the community. And that's pretty much it.
Awesome. That's it. No big deal. Just this incredible tech. Thank you so much for walking through that and showing us just the surface level of some of this really cool stuff. I know we're all very excited for when the sample comes out and everyone can actually dig into it themselves. But thank you so much for walking through that. Really appreciate your time.
Thank you.
All right. Well, next, I think we'll hand it over to you, Brian, if you want to talk a little bit about some of the rendering updates that came out.
Sure. I'll start with Nanite because that's the thing I'm closest to. Had been doing a lot of work with the dynamic tessellation for Nanite, going on for a couple of years now, and it's some people saw that was in a work in progress state in the 5.3 release, but we weren't really ready to release it quite yet, and that time is now for 5.4. It's still in an experimental state, but it's actually like ready to be used, with some expectation that it won't be terribly broken like it was kind of in 5.3, which is why we didn't like document it and talk about it because it wasn't really ready yet. But it's ready to try out. I've gotten some questions as far as like, why do you need to generate more triangles when the meshes were so highly tessellated already with Nanite? Like, do we really need smaller triangles? And there's some good reasons of why you might want to use a dynamic tessellation instead of just the highly tessellated, just high poly meshes that Nanite allows. There's just cases where you want to create some like procedural detail, places where it wouldn't have made sense to create a bespoke high poly mesh for just that situation. We go into a bit more on this in the breakdown that we did of the Captain America and Black Panther demo that we showed off at GDC. I don't really have a lot of materials here to show you, like some of my other
No, that's fine.
partners here on this stream, but yeah, I'll just kind of to speak to what the various stuff that the rendering team has released in this. So there's the reasons why you might want to use hardware tessellation is this sort of like procedural detail cases where you'd have say where you would normally want to use like tiling textures and normal maps that you wouldn't have built out the actual like geometry of meshes. Say you've got like a cobblestone path on the ground, and you want that to twist and wind around. It wouldn't really be practical to create a unique, gigantic, high poly mesh of the entire like walkway in cobblestone. What you'd want to have is a reusable bit that is replicated along it. You can try to do that by placing many instance meshes, but that's a hard thing to do. We've got spline mesh support, which is also kind of ready for prime time now with 5.4. That's one of the things that we released. That might be a use case for that, but there are other places where that doesn't make a lot of sense. You know, that spline meshes can follow like particular paths, but you might want to have a displacement go over a more complex surface. So the dynamic tessellation feature allows that. I guess I'd say that be careful about the cost of it. Unlike nanite, that in most cases just like base nanite with high poly meshes scales pretty well. It's mostly, unless you get cases of the like heavy foliage and overdraw, it mostly scales to just the how many pixels you've got on screen. Tessellation is a bit heavier of a feature, so be careful in where you use it. I wouldn't recommend necessarily covering your whole game with tessellated materials and surfaces if you're trying to hit like 60 hertz on a console, for example. But if you've got a higher end hardware or you're not shooting for real-time like game sort of frame rate, yeah, you can use it in a lot of stuff. I guess the one recommendation, one thing that I would highlight that we tried to highlight in the docs, but one thing I would recommend is be careful with what your magnitude setting is on the displacement, because the larger that magnitude is, that controls the overall bounds of the patches that are rendered for culling purposes. So try to make that magnitude value as small as possible so that you can use the entire range of that magnitude when what you're actually outputting to the displacement pin. But with that, I'm really excited to see what everybody does with it. We have a number of other improvements that are coming out in 5.4 for nanite. I mentioned the spline meshes already, but we also have compute-based shading. It used to be pixel shaders that were these like full screen quads that were drawn on the screen, but we switched over to a complete compute shader-based material base pass. With that, it should mostly be transparent to you. It'll just run a bit faster. But some of the features that allow it to run faster is that we've got software VRS that has now been enabled with the compute pipeline. So whether your hardware supports like hardware VRS or not, you can have variable rate shading working in a software supported way. So basically you can have variable rate shading working on all platforms that support nanite. And that does accelerate your nanite base pass by quite a bit. Some other optimizations that came in there was some removal of what we call empty draws, because nanite is a GPU driven pipeline. We have to do a draw call or a compute dispatch for every single material that is present in the scene, whether it's actually like in view or not, because whether that's in view isn't really known on the CPU that is launching those draw calls or those dispatches. The CPU doesn't know about it because it's a GPU-driven pipeline. So we need to have the GPU be able to trim that stuff. We don't quite have the API control to do that everywhere on all platforms, but we've added that on the platforms that we do have the ability to trim things on the GPU for the stuff that isn't actually visible, so you don't get this cost of these empties. And when you get a lot of empties in a row, that adds a bubble in the pipeline that just means your GPU is idling and not doing real work. So we can get rid of those bubbles and make it so your GPU is just running at full bore, which is what you want it to do. So that's kind of some of the stuff happening with nanite, but there's been a number of other rendering features that have come out with 5.4 as well. TSR has some improvements, a really cool thing called history resurrection, where because TSR and any other like TAA sort of technique is accumulating samples from many frames, anytime you get a disocclusion where an object is moving and it then displays what was behind it, where you get a first frame, you now have a place where there couldn't have been an accumulation of samples. So you're seeing some bit of the scene for the first time. Anytime that happens in a TAA or particularly a temporal upsampling case where you have even less samples that you can add each frame, so there has to be a lot more accumulation. Those areas tend to not look great. They can be noisy, they can be higher contrast, they can look lower resolution. History resurrection means that if in the recent history you have seen that and it was just something like passing by the screen, for instance, so you saw it, then it was covered, then you saw it again, we could be able to resurrect that frame where you previously saw it. So it was occluded and then you saw it again. We can resurrect that bit so that you get an actually like accumulated resolved bit of image that doesn't look as noisy or low res. So that's a cool addition for quality for TSR. Some other stuff. It's we've got support for orthographic cameras. I know this is a thing that some people in the enterprise space really are looking for. It's something that we haven't really supported well, like we supported in wireframe rendering and stuff like that, but actually like fully lit views in orthographic have been something we haven't supported for a long time, but done the work, and that's ready to go and release now. Another thing that was shown off in that GDC demo with Captain America was heterogeneous volumes. So this is like full like volumetric rendering where you can have smoke or fire simulations and have a ray actually like march through that volume instead of having what so much effects that have been in video games for forever have been sprite based, and effects artists have been trying to fake the fact that you have a real sort of volume of smoke or of volumetric fire. Instead, they've got just a camera facing sort of billboarding sprite or a collection of many sprites that are all compositing together to try to fake that volume. Well, with this heterogeneous volume rendering feature, you can combine that with OpenVDB files that are actually like volumetric, pre-computed volumetric sims, and do that. Use this feature to render them, to light them, for them to cast shadows onto the scene, for them to cast shadows onto themselves. You can combine it with and import VDB files. You can also do it while just like running a shader. It's the ability to have a sort of a volumetric function that can exist in the scene and receive lighting and cast shadows and all that sort of thing. So it's in an experimental form, and there'll be some more optimizations and kind of build out of the feature matrix, make sure that interacts with all of the various different effects on screen, so that it's nicely integrated into the frame. Some more features and fill out of that will come in time, but it's already in a pretty nice state that we were able to show it off and look really nice in that demo at GDC. Some less about so we also have some work that has been done that's less about like sparkly pretty pixels and is just about optimization. So I know that the community has reacted pretty positively to us talking about the sort of frame rate times or the improvements that happened with the city sample. A big part of that was render parallelization work that has been done to trim down the render thread time by having better parallelization of the work on the render thread. A lot of work and a lot of improvements has been done there and continues to be done, and we're still doing work and making improvements going forward, but a good chunk of that is coming out or has come out now with 5.4. So we get some really nice improvements. A good, like in some of our test examples, like cutting the render time cost like in half. So it's like really big improvements there. Another bit of optimization is a lot of work has been done into reducing the time or the amount of shaders that need to recompile when changes are made. I know it's been an issue that have plagued users for years using Unreal now, of like just having to wait for all of your recompiling shaders. So this is something we're really trying to attack to bring down both these sort of like interactive when you're in the editor, as well as improve overall like cook times when you're just trying to cook the game, because cooking needs to compile shaders if they're out of date as well. So we've made some nice improvements for trimming, both in the way of trimming down the number of shaders that need to be compiled, because we have better detection of what stuff is out of date and is not, as well as trying to improve the actual like time it takes to compile the shaders themselves. So good improvements that have come in 5.4 there. Let's see. Some work has been done in bindless resources. That's still very much in progress, so I think it's a kind of experimental state right now. I'm not sure whether it's you still be able to use it without getting some crashes, but it is work in progress, and a good bit of that work has come out in 5.4. Another bit that is in progress and is out in an experimental form, at least, is ray tracing on Vulkan. So that should kind of match up to the same feature set that's been in Direct 3D side of things, but now you can use ray tracing in Vulkan, or at least in an experimental form. You can. See, speaking of ray tracing, a lot of improvements that have been done in ray tracing performance side of things. A lot of optimizations. The general sort of shift is we're focusing a lot more on trying to get hardware ray traced lumen to be kind of the sort of primary mode, instead of the distance field tracing. Distance field tracing has been, up until now, the fastest way of doing it, and is still that way for certain types of scenes. But we've shifted more resources into trying to make the hardware ray traced lumen kind of the primary mode, because we've seen some early evidence, as well as some experience once we've made some of these optimizations, that can actually be competitive from the performance point of view, and it certainly has benefits from the quality side of things. And it's only going to get faster as hardware ray tracing in the GPUs evolves. That's moving at a very fast rate from architecture to architecture when the new video cards, new GPUs come out. So we're fully on that sort of path, and are making improvements for it, and a batch of those improvements have made it into 5.4. Let's see, what did I miss? Oh, lastly, or one of them I missed. I don't know. Lastly, yeah. Large world coordinates on the GPU. There's the wording on this is a little confusing. There's just some things in our release notes that say like double precision. It's not exactly. We don't support doubles in shaders. That's actually kind of a misnomer. It is large world coordinates as supported in material graphs and in shading now. But it's using a different format than like your traditional like double float that you'd get in like C++. The reason why is that not all GPUs on all the platforms that we support actually support doubles. So that's one problem. And the ones that do support doubles, the performance for doubles in shaders is just usually very slow. So instead, we've got like an emulation for a high precision format using this format called a dual float. So you have two float values, one cating the sort of high bits, and the other taking the low decimal places. And those two together form a higher precision number. It does not have exactly the same sort of precision that a full double will have. But it should be higher performance and supported across all platforms. But that support is out in 5.4. So in places where you have absolutely gigantic worlds and just massive games, and you want to be able to do some of this like math in your shader to do like world space coordinates sort of world sort of deltas between actual like positions that you're trying to calculate in world, and you're trying to do that like in your material, and you're trying to do that really far from the origin. If you didn't use this new feature, you'd have major sort of like stepping and banding artifacts because you don't have enough precision far away from the origin. Using this new higher precision LWC support should be able to improve those problems. I think I covered all of it. Looking at the release notes now, I think, yeah. Oh, I missed I missed one at the top. Neural network engine is released with 5.4. So this is our like abstraction layer for neural networks coming into the engine. There's various different things that it supports, but it allows us to abstract what those end APIs are, whether that's running ISPC on the CPU or whether it's through direct ML. This is our like abstraction framework to be able to get neural networks and do inferencing on the runtime. So exactly what that can be used for was yet to be explored, but the framework is released in 5.4 to allow people to start exploring that.
Yeah, I kind of love that, honestly, that there's not necessarily a very specific use case for it. It's that the tool exists. Now experiment, see what you can do with it. I love giving that kind of creative freedom over to developers and seeing what they can make up.
Yeah, so I mean, we've tried already. It's not like we've not used it for anything. So we've got some experiments already of having full screen post processing, of doing like style transfer sort of stuff, and we've done some experiments to use it. But really, it's a very active and fast moving field, the AI right now, and exactly how that ends up impacting rendering is anyone's guess, but getting those sort of foundations to be able to explore that is what this is about. So we'll see that starting entering more into real-time rendering in time.
Yeah, definitely. Well, thank you so much for walking through all of those. I know that I think my favorite comment I've ever seen, especially in regards to the compiling shaders, was someone said that they don't know who they are without their shaders compiling. So we're giving developers identity crises. This is fantastic, though. Thank you so much for walking through all of that. And again, I know a lot of stuff was covered there, but if you have any questions about any of that, please make sure to toss them in and we'll collect them for Q&A at the end here. Then next, last but again, certainly not least, Ben and Ryan. I'll hand it over to you. I know you were going to talk to us a little bit about Horde, I believe.
That's right. Yeah, I'll pick it up to start off with. I think we're switching tack a little bit because we're not talking about stuff that's in the engine so much. In general, I think one of the strengths of Unreal has always been in the tooling, like a lot of the things we've seen in the stream today. But that historically, that tooling is kind of stopped at the editor boundaries. It's all stuff that you run on your machine, and that's the kind of limit to it. And to actually successfully run a project in production, when you have a bigger team, you have to get everybody to work together and so on. There are a lot more things that people need to think about. And we haven't really sort of dictated or encouraged anybody to use any particular solutions for those things, but every team has to go through it, and there's a lot of sort of reinventing the wheel on that stuff. There are lots of third-party things you can use to help a team work together. There are things like build automation systems like Jenkins or TeamCity, things like that. Maybe to improve your build times, then you might want to have some distributed compilation solution like IncrediBuild or SNDBS or FastBuild, something like that. You might have to set up some network shares and so on to be able to distribute builds to people, all that kind of stuff. And in general, they're all very segmented and it's quite janky sticking them together. And we wanted to, like internally at Epic, for our own use cases as much as anything, we wanted to be able to combine them together so that we can smooth out some of those joins, make it so they work together really seamlessly, that everything has the right context to be able to sort of dictate how the next thing operates and so on. Just kind of reduce the cognitive load that it takes for people to work with other people on their team, and to also kind of selfishly for Ryan and myself reduce the overhead deploying and managing this kind of stuff. When there's a different tool for every aspect of production that you get into, it gets quite difficult to just keep things up and running smoothly, keep it optimal, that kind of stuff. So about 5 years ago, we started working on a product called Horde, which I'm going to talk about today. We developed it internally, and we've been working with it for, like I say, about 5 years now. I think Fortnite has been shipping on it for the last 4 years. And the 5.4 release is the first time that we're kind of, it's all been in GitHub and Perforce and been accessible to people for a long time now, but we haven't really given any instructions on how to use it or even kind of explained what exactly it is. It's just been like a bunch of source code that's there. So 5.4, we're going to make making our first attempt at trying to open it up to other people. We've talked to some other licensees, they've tried it and had good results with it. So I'm kind of here evangelizing it today. So maybe if I can share if you could share my screen, Dan. So this is the GitHub repo. We've got the release note for Unreal Engine 5.4. There is an Unreal Horde server MSI attached there, so it's like it's an installer that you can run on Windows. We do support deploying it using Docker on Linux as well. That's in the packages section of the Epic Games organization. There's also the full source there in the engine source programs Horde folder. There's lots of docs in there. And when you install that, you'll end up with something that looks a little bit like this. So this is the welcome page for Horde. We set this up as a server so that everybody can connect to it. And the first thing you see is this welcome page that gives you a guide to setting up lots of other bits of functionality that your team may or may not want. It's important to sort of emphasize that all of this stuff is, I know that a lot of teams will already have existing solutions to these things, and so they may not want to take aspects of Horde. All of these things are enableable individually. So if there's something that you want and something you don't want, that's absolutely fine. We don't sort of force you to use everything. But one of the things that we found developing it internally is that the more stuff that we include with it, the better sort of cross-referencing we can do between things, the less duplication of effort that we have, the easier it is for people to discover things and to work with them. So I've got this Horde server set up, and I've connected it to it through a web browser. I have, if I go up to the server tab here and go to the agents, you can see I have 6 machines which are connecting into my my Horde server, and the architecture of Horde is such that it's trying to solve, at its core, 2 problems. There's lots of different services which are sprinkled on top of it, but there's 2 core problems which it's trying to solve. First is like coordination of different machines. So you have a bunch of, if you have a bunch of spare machines, and you can connect them into Horde and you can send work to them. So you'll be able to distribute work that you would, things like compiling your shaders, like you can do that on other machines rather than doing it on your own machines. The other aspect to it is storage. So there are a lot of things produced during, like if you run builds and so on, if you want to share that with another person on the team, then you could upload it to Horde. Yeah, lots of other things, lots of the little tools that we sort of end up building on have a need for storing artifacts of some type or another. So they can all use Horde for that. Anyway, getting back to the main bit of the demo. So this is what you get when you install Horde for the first time. There's some instructions there on how you set up agents, which I've already gone through. Probably the easiest entry point that I think to sort of showing what functionality is in Horde is to look at build automation. And build automation meaning continuous integration, continuous delivery, all those kind of buzzwords and jargon, kind of like Jenkins or TeamCity and so on. But that acts as a really good jumping off point into other bits of functionality that Horde can provide. So even though I'm going to demo some of that stuff now, you don't have to take that if you don't want to. It's just a really good place to show how things fit together. So I've set up this Horde server to point to the 5.4 release branch using the instructions that are in the documentation, and the defaults that it comes with. Set up a bunch of build processes for you so that you can You can like build your editor, package your game, do all sorts of things like that. So I'm going to flick between these different tabs, which have different types of jobs that they run on them. The first one here is the incremental tab. These are all customizable, by the way. Like it's all config file driven, so you can set this up however your team wants to work. But the idea with this incremental tab is that as developers are checking in changes into your branch, then this is just going to run some build jobs on it just to make sure that everything compiles, everything works properly, and so on. So we have a bunch of jobs here. You can see Hellgaze over there as well. This integrates really closely with Unreal GameSync, which is another tool that we've been publishing for a few years now. In fact, Horde has a download page where you can download Unreal GameSync for it. Unreal GameSync is kind of like the client-side application that developers can use to sort of sync down changes from other people and so on. I've got a copy of it up and running here. This is all the changes that are in the 5.4 branch. You can see all of the changes that people have checked in, whether it's a code or a content change, and you can set it up so that you'll be able to see like whether certain things have succeeded or failed in Horde in this column here. I haven't actually done that, but anyway, all of these incremental build jobs that we have here, these are building the editor. In this case, I've got it set up so that it's building the Lyra editor, a Lyra sample, and as part of that, it's producing a build of the editor. If I click on Browse here, you can see that there's the engine folder, which has a bunch of DLLs and executables and all that kind of stuff in it. And if you wanted to, you can browse through all of this stuff and download them individually. But you can also just download the whole thing either as a zip file or there's another way to just download it with Unreal GameSync. You don't have to go to the Horde website to be able to do this. If you look in Unreal GameSync, the one I had set up over here, you'll see that half of these changes are grayed out and half of them are rendered in solid font. All of the things that we've built an editor for show up in solid. So there's Helga's change over there, corresponds to this change list that was built over here. There's Sergio's change over here, corresponds to this one over here. And if I double click on one of these things inside Unreal GameSync, it will not only sync down everybody's code changes, source code changes, all the assets and so on, it will also sync down those that build of the editor. So if you have content creators who are working on a project at the same time as engineers, then engineers can be checking in changes left, right, and center. And whenever there's a build of those changes available for content creators to download, they can come to Unreal GameSync and just double click on one of these changes and it'll fetch everything down for them. So that's the incremental tab. There's also some editor tests that we have set up here. So this is the kind of thing you'd maybe run slightly less frequently, but what it's going to do is build the editor and then run some of the tests that we have built into the editor using Gauntlet, which is our tool that's part of Automation Tool for coordinating different machines when they're running tests. So those are just jobs that run, but what they do is they pipe data into the Automation Hub over here. So I can go over to Automation Hub and I can select Engine Test, and that will populate with the results of all the tests that have been done. So we can see that there's lots of parameters I can filter things by down here. I can expand the list of rendering tests. This will normally show, if you have like a fairly big team and you have lots of different branches, this will show you the results of running the same test in every branch. So you can cross-reference whether some change that was introduced into one branch is causing a failure or whether it's exists in some other place. But I can see all the results of running tests over here. If I click on that, I can expand into it, see all of the different tests which were run. I can drill down a bit further, see a little timeline of when things started to break and so on. This is a test which has screenshots in it. So some rendering tests that have failed because there's a reference image for what it's supposed to look like, and then there's an image for what it actually produced. And I'll show you the difference in there as well. Kind of just helps getting on top of when something broke, what the actual problem is, be able to drill down to the details of it. So that's Automation Hub. Just going over this stuff very quickly. All of this stuff is extensible and you can build a lot of functionality into it. This is like a completely custom instance that I set up yesterday for being able to demo this stuff. As I say, Epic has an internal instance of this, which we use for Fortnite and building Unreal Engine releases and so on, which has a lot of stuff into it. So this system is kind of proved itself out to be quite scalable for our needs and also pretty adaptable to whatever our game teams come up to us and say that they want it to do. Moving on through the tabs here, we have this package build tab. This is set up to build Lyra again, and I can click on one of these jobs and drill down into it and see all the various steps that were run as part of this. All of these build processes are scripted using BuildGraph, which is another tool that we've had in the engine for quite a few years at this point, but we haven't provided any of the server infrastructure for being able to run it. The idea now is that we can give a kind of golden path for being able to develop projects like our samples and so on, and that will integrate directly into Horde so that you can build them and have a team working on some similar sort of project in no time at all. We can go into the details of any of these things, and we can see that there are warnings in this one and so on. There's this really long log that's produced through it, which is all nicely virtualized, so you can just jump around it very quickly and get to the right, the interesting bits. But anyway, this package Lyra build here, you see it produced a package build top here, which similar to the engine build that we saw before, you can just step into it and look at the individual files and just see all of the outputs directly in line and just download it as a zip file if you want to be able to use it in a playtest or something like that. The last bit which I was going to talk about is in the remote execution tab. So I mentioned before that one of our goals with Horde was that we kept on seeing all of these different tools which were kind of reinventing the wheel to some degree, to do with like if you have like say Jenkins for your build automation system, and then you have something like Incredibuild or SNDBS, they're both kind of managing a bunch of machines and deciding which machine should do some bit of work, coordinating between them, and deciding which bit of machine can do work at any particular time. And the sort of scale that they're working at is a bit different. When you're talking about a build automation system like Jenkins, then all of the individual steps that you're running are probably quite long-lived, and they keep an entire machine busy for, I don't know, like 10 minutes or an hour or two or something like that. Whereas if you're running some C++ compile, you're spawning lots of little compiler processes, and each one of them contributes towards the end result. So it's a lot more fine-grained. But we designed Horde with a mind to sort of providing a platform for being able to do this stuff in the general case. So as well as using it for the kind of coarse-grained stuff like the build farm itself, we also have a remote execution tool on it, which you can use for improving your C++ compilation times. So now, rather than having to compile everything on your local machine, which is what's happening in this job here, you see it took 48 minutes to compile the Unreal editor. It's quite a long time. But if we enable the remote execution functionality, which is using a tool called Unreal Build Accelerator, the build time drops down to 11 minutes and 57 seconds. And what it's doing during that compile, if I just go into the log here, you'll see it's spitting out that like it's compiling this CPP file, and there are lots of different remote executors attached to each one of these things. So when it's doing that build, then Horde is reaching out to these other machines and saying, you know, you can help out. You've got some spare CPU cycles right now. You can help out building this CPP file. So it sends off all of the, it virtualizes the environment on that remote machine, or it virtualizes the environment of the host machine on the remote machine, transfers all the CPP files over, builds them remotely, and then fetches them back to the source machine once it's done. And we use this a lot now at Epic. All of our products are built using this. We have a massive farm of at least 2,000 machines that are in the cloud, which are used for it. You don't have to use cloud machines. You can just use regular workstations or whatever. I did actually want to set up a demo that used a Raspberry Pi to host the Horde server, because it's really not that taxing all the work that it needs to do. But it's a super powerful technique, and it's one that we're going to sort of invest heavily on in the future. At the moment, we're with 5.4, we're productizing this functionality that allows distributing C++ compilation using Unreal Build Accelerator and Horde. We have internally a system which uses something which uses the same stuff inside the editor to do shader compilation. So rather than having to do all of that locally, you can distribute it to other machines that have spare cycles on your network and so on.
And then expand on that for you a little bit, Ben, too. Like with 5.4 release, we're touting kind of the Windows platform is definitely ready to go. We're calling it beta for 5.4. So anything Windows, including your consoles, Microsoft, Xbox, PlayStations, Switch, all kind of can compile through UBT and UBA. And we've got in kind of experimental state in 5.4 is support for macOS and Linux platform natively, which we're working with those internally as well. So we're seeing lots of compile time boosts on all of our platforms internally running on Horde, Fortnite, and we built Unreal 5.4 and released it using Unreal Build Accelerator. So we've increased our compilation time there tremendously, and it's been great for us internally. We're hoping licensees will test it out for us and let us know how it works for them too.
Yeah, absolutely. There's a lot of other functionality that we have in here as well that I'm not really going to touch on today. So Horde includes a system for if you have console devices, if you're working on PlayStation, Xbox, or Switch or something like that, then it has a device manager so that you can have a shared pool of devices that people can borrow a kit from and then sort of put it back in afterwards. And all of the automated test functionality that runs on Horde can also interact with that system and be able to check things out. We have an analytics system in there as well, so that I don't have it set up here, but there's a screenshot of it inside the docs where you can configure people's editors to send telemetry data back to Horde and get some insights into what's the things that are slowing them down, like how quickly it is to open certain maps. Those kind of getting a state for the health of your team at a sort of macro level through functionality that's already built into the editor, and probably a few other things as well that I'm forgetting to mention.
Yeah, we're starting internally. We're tracking metrics on UBA. We want to know, eventually how quick to get a first helper for like things with UBA, any failures, and kind of the distribution of like how much is a job being getting route helpers and how much of it is being executed locally, so we can kind of understand the health of our systems. And like cook times, we're monitoring what our cook times look like. We can easily identify cook time regressions and all those fun things.
So it's still pretty early days for, as I say, this has been in development for a long time internally at Epic, but it's still pretty early days for us productizing it and giving it to you guys. And we're really eager for any feedback you have about it. Even better, we're really eager for any pull requests or fixes that you find that are sort of outside of our golden path that you might run into. So we're really eager to get feedback from people to help us sort of shape it and define what it's going to be in the future. It's quite we've kind of tried to make it this kind of programmable platform more than anything else, so there's more things that we can build out on the top of it in the future, and hopefully we'll be seeing a lot more of it in the years to come. Anyway, that's it for me.
All right, fantastic. I want just making sure I'm not going to interrupt anything. Ryan, did you have anything else that you wanted to add in? Okay.
Okay.
Awesome. Didn't want to just be like, all right, moving on. While you're like, wait, no. All right. Well, thank you both for walking through that. There's a lot of really good information there, especially for, yeah, I mean, chat's freaking out. So they're excited about it. Lots of things that seems is going to be really helpful for many of those particular developers for their iteration usages. All right. Well, if y'all are up for it, I think now we can go ahead and spin into our Q&A section here, and I can just absolutely pepper you with a bunch of questions, and we'll go through it a bit rapid fire here. I'm not going to make it too long, just in, being conscious of y'all's time. You're very busy people, so I'm going to go through, try and make sure I pick out the ones that I've seen pop up the most often, but also for everyone watching, if for whatever reason we can't get to your question, if you had posted it, all of them are logged. and we'll go through and see if we can't make sure that we can get some answers out to y'all in another format at some point. So no worries, your question will be answered in some capacity, but we gotta be a little cognizant of time here today. So to start us off, I'll just go back to the beginning here, and the first question, I'll actually just answer it myself, is about if there is a patch 5.4.1 in the pipeline. 5.4.1 is actually out right now. You can go get it, and I recommend you do. So there you go. There's your answer. Go get that. Then
there's also there's a 5.4.2 in the pipeline now as well.
Yes. Thank you. Exactly. But that's later. So that's a tomorrow problem, right? All right. First question here for y'all, though. I'll go ahead and toss this over towards Chase and Helgi, although obviously if anyone has anything else they'd like to add, feel free to do so. A lot of people were curious for the modular control rigs if your character has to be pre-rigged and skinned in order to actually get it set up for that.
I'll start it off. Yeah, well, so the modular control rig doesn't handle skinning and bone placement. You can create bones within control rig and the modular control rig editor. But weighting them, that's all done through the skeletal editor, which unfortunately I didn't dive into just because of time on here. But we have a lot of great examples on that. It's a new feature we brought into the engine in 5.3's experimental, and we marked it up to beta in 5.4. So it's had a lot of really cool updates since 5.3. And that's where you would go and build your bones and weight your character. Then you take it into modular control rig and then continue on from there.
Fantastic. Next question here still looks like for the control rig. Is there an X-ray view to see any controllers that may be inside the mesh?
Why, yes.
Yes. Yeah, we have a, I think it's called overlay. You can enable it in the edit mode when you're in animation, in the animation environment. So when you're in sequencer, you can enable that, and then you're going to see the controls shine through the mesh. And there's also, that's actually using a material, and you can absolutely also build your own material and use that on the shape library to give it a different look and some other, overlay that you may want.
Very nice. Next question we've got here is, will animation code interact with modular rig, or is it just for manual control?
So, Chase, you want me to take this? I think it's concerning runtime.
Yeah, that's how
animation.
I interpreted. Go for it.
I hope I get this question correctly, but basically, yes, you can use it for linear content creation, like Chase was showing, like use sequencer and create animation. You can also run control rigs as part of the animation blueprint and drive them procedurally. We use this a lot in our internal projects for fix-up kind of things, like fix-up shoulders, those kind of problems. So you'll build a rig and then procedurally drive it with a locomotion system driving it, for example. It's absolutely something you could chain together. Yeah.
Fantastic. Is it possible to offset modular controls?
Yes. I guess what you're probably referring to is, I guess, taking the control and moving it to a new location after it's been built. Yeah, if you look in the, depends on the module too. You can click on the module itself, go to the details panel, and there's some settings in there usually to move the controls around, specifically the shape. If something isn't exposed, there's no reason why you can't double click the module. And if you know what you're doing, you can go in there and expose it yourself too. We kind of offer that. That's a really nice flexibility of the system, is that you can kind of edit it right on the fly and if you need to.
Very nice. Next question I've got here for, we really are full rapid fire right now. This is awesome. Next is, retargeting now works with all skeletons, but do you still need a retargeter? For example, Sinti skeleton, or are those also in engine by default?
That one I would like to defer to. I don't know. That'd be a very specific question to Kieran Ritchie, who is our engineer for the retargeter.
I can answer how we're going to do it on the game animation sample. We're going to provide a retargeting asset for the more common skeletons that we've released in multiple projects. So UE5, Mannequin, UE4 mannequin, Echo, metahuman, those kinds of things. So they will be there.
Awesome. Perfect. Next question is, can we do a mix of dual quaternium and LBS?
You can. So I believe in the function that we're shipping with the deformer graph. That's actually not set up right now. You kind of get one or the other. But as they're built, they are functions. So you can dive down in there and kind of modify it or take the code and build like a nude function and expose that. That's kind of how it's set up right now. But definitely something we're looking towards being able to paint all of these deformers in specific areas to do exactly things like that.
Fantastic. All right. Then the last question that I think is mostly aimed towards you two so far, and it's a bit more of an opinion piece than anything else, I think, but it's kind of fun. What animation feature do you feel was the biggest leap forward in this release?
Go for it, Helge. You take this one.
I feel like this is a dangerous question. I'm obviously very biased. Well, I feel like looking at UEFN and less technical users, I do feel, even though that's my primary piece of work, the modular rigging is really important because rigging is something that is perceived incredibly technical and hard to approach. And with this, we're making it possible for many more people and much less technical people to build characters. So I feel like that has a big impact. Not saying that any of the other features aren't important and impressive, but I feel like in terms of audience, this is an important change.
Wonderful. What about you, Chase? Did you have an opinion on that matter, or?
Similar to Helge, I have a lot of passion towards modular control rigs. Spent a lot of time on constructing the modules and working together to make that whole system work. But really, to me, it's our entire animation ecosystem. I mean, all the tools have taken a step up, and we're continuing to take them steps up on each release. And how you can interface between all the tools, all the work I did today and roughly half an hour. If we're jumping between other software, everything I did today would have taken immensely more time. It would have taken hours, just trying to get data across or, something to go correctly. So to me, that's the real powerful part of what we've done in 5.4 is that we've really expanded what you can do within all of our tools.
Yeah, definitely. Awesome. Well, thank you both so much for that. And of course, even though the rest of these are not necessarily directed at modular control rig, that does not mean you are not allowed to speak. So feel free to jump in at any point on some of these other questions as well. Next, we'll get into the ones that seem to be aimed mostly at motion matching. So the first one is motion matching. I'm going to stumble over that at least 4 times. I call it already. Is it stable for mobile devices?
Well, Fortnite has been using motion matching on mobile since December. So you will have to be careful about how big your databases are and do some manual tweaks. We offer tools to look at that. But yes, it runs. It's stable for us. Hopefully it's stable for you, but we definitely use it.
Fantastic. That was the best mic drop ever. Well, yes, because we already do it. All right. Next up, I do also, like I said, want to be cognizant of everyone's time. So if any of our guests need to drop at any point while we're going through Q&A, that's totally fine. Feel free to do so. Thank you for your time in the meantime. But we'll keep going through while we've got you. Next question. Let's see. Okay, I'm going to redirect a little bit. We'll come back to you, Jose, with a few more motion matching questions, but I'm going to focus a little bit more on the Horde stuff real quick. Main what we've got here is, will the 5.4 Horde installer, etc., moving forward, work with 5.1 or any of the other previous versions of the engine?
Yes, it does, absolutely. We actually support, there's one project still at Epic that's running on the UE427 release, I believe.
We've got
and that's running on Horde as well.
We have UE 4.27, and we have like our EOS and the Epic Game Launcher, or all UE 4 based projects, and those are every day working on Horde.
Fantastic. So, yes. Wonderful. All right. Okay, now we'll ping pong back over. That was the main one, and I wanted to make sure I could ask both of you. Moving back over to motion matching here. Let's see. when doing motion matching for several different types of poses, for example, if you had 3 different poses, would you need to make 3 pose search databases, or can you combine them?
I don't think I understand the question very well, because motion matching it makes poses, like individual poses of individual frames, but you're working with animations. So if it's 3 animations that make sense in the same database, then put them in there. Our tooling, like when I showed the chooser versus database setup, the idea is that you want to start by dropping everything in a single database and see if you get selection problems. If you get selection problems, either you tweak your schema to make your matching better, and if that doesn't work out, you separate it into choosers and have some manual selection before the motion matching selection.
Perfect. All right, let's see. Would it be possible to add different overlays in the motion matching sample? There's number 2.
So we actually have a tech talk from GDC where we talked about the Fortnite layering setup. In Fortnite, our layering, like we had one unarmed base set, and almost every single weapon was layered dynamically on top of that unarmed pose. 2 things to pay attention for here is that single poses are somewhat easy to layer on top. But if you are layering animation, it gets complicated because motion matching, it doesn't work with sync groups. It is a different concept. So you need to find a separate way, either with a separate blend stack where you're pushing your additives over and over, or using the motion matching graph that I showed before.
Fantastic. Next question here is, how is motion matching performance compared to state machines in the ABP?
Could you repeat that one? Sorry, I don't think I understood that.
Absolutely. How is motion matching performance compared to state machines in the ABP?
Okay. So the selection, we actually measured it to be faster than some of the previous cases that we had in Fortnite. Sometimes if you're searching 500 animations and you are unlucky with your search, it is going to perform worse. But generally, I've seen projects that super optimize the state machine, and to get to that point and motion matching already being comparable, it's pretty good. I'd recommend trying it out and profiling with everything.
Awesome. This next question here, this is another probably more an opinion piece than anything else from you. But when would you recommend using motion matching? We're at 3, I told you, versus using blend spaces?
Well, number 1, you can use blend spaces in motion matching. So that's a nice bonus. I won't say that feature is probably not as production ready as everything else that is around motion matching. But generally, the idea is this: if you have like a specific place in that blend space that you want to be at, then motion matching is fine. But if you want some like additive layering on top, then no blend spaces. Like I can give an example here. Leans, I would recommend using a blend space that's out of motion matching for that, and that's what we do in the sample. We have an additive lean that lets you do the leaning, and when you reach a discrete threshold, then we switch to an arc animation. That's how I would recommend using both.
Fantastic. All right, well, with that, those were the main ones, I think, for motion matching. So now we'll get into a couple of rendering questions real quick. First one here is, with these new rendering features, do you think it pays to migrate to Substrate?
Substrate is not really production ready. So I guess part of the answer would be they're orthogonal. Substrate is not really connected to any of the features that I discussed today. But as far as moving over to Substrate as a separate question, I don't think we're currently recommending that yet. It's still in development. It's still in an experimental state, so I don't think we recommend it for production use cases. It's there to experiment with, and it is functional. We've showed it off over, I guess, a year ago now in the Electric Dreams demo. So I mean, there is something to work there, but yeah, there's still some work left to be done to get it to the point where the kind of key thing that's holding it back, the thing that we're looking for to get it to that point, is we want to make sure that there's no performance regressions, and our test case to show that there is no performance regressions is that we'd be able to enable it in Fortnite, not necessarily to use the new feature set, but just to move over to the new framework such that we can deprecate the old code and have everything running through the new like substrate framework, and then be able to start using its new features. But just to make that sort of like baseline, if you're not exploiting any of the new stuff, just the baseline performance of it to be at exact parity. And it's not quite there yet. So we haven't been able to do that switch, and that's the reason why we haven't yet said it's ready to go. So I guess it depends a lot on your situation and what you're looking to use it for how I would be able to answer that.
Fair enough. All right, this next question, and you may or may not have the answer for this one, but we'll see. Is there a reason that the displacement intensity was moved inside the material tab versus it being able to be set as a parameter as they could with the old displacement?
I very much can answer that. The reason why is I need to know what that parameter is in a fixed function shader that is doing culling of patches. It needs to not be shader driven logic. It needs to be something that is just a number, and a number that can be just queried off of any material. That number, that magnitude, is controlling what the min and max possible displacement that can happen off of the surface. So I can use that to determine what the bounding box for patches or sub patches that have gotten tessellated, for how big they are on screen, what their bounding box would be, so it can do frustum culling or occlusion culling. I don't know what the exact displacement is, because that would require running the shader to know it, and then you've got like a chicken and egg problem. I need to know. I wanted to be able to cull those things before doing the work to tessellate them and displace them. And the only thing that I have to work with as far as the overall bounds is what that min and max possible is. And that's also the reason why I stated earlier that you should be very careful for what you set your magnitude for, so that you don't set it to be a really large possible magnitude that gives you a full range of possible values that you'd use in displacement and then use only a small portion of them. You really want to set that magnitude such that you're using the full like 0 to 1 range of displacement, so that is acting as a good actual bounds for your displacement function, so that your bounding boxes are as tight as they possibly could be.
Awesome. Then the next question for you is, would you recommend nanite tessellation for things like cinematics and or non-playable experiences in games, or do you feel it's better used for other media besides games?
I think it's even useful for games. I just want to caution you as far as like what the cost is there to hit like a 60 hertz console title, that it's going to have some expense that is more than if it was just a high poly nanite mesh. That doesn't mean that it's necessarily so expensive that it can't run in real time or in a games context. It's not equivalent to if you just did the like static displacement feature, or like sculpted out what that displacement was in a high poly mesh and made it a normal like nanite mesh. It's going to be a bit more expensive to use the dynamic tessellation and displacement. Like it has to evaluate the displacement shader. Like that's just part of the cost, and then there is an additional cost, relatively small, but there's also a cost of doing the tessellation work outside of just rendering the triangles, which is what nanite's normally doing. So I guess I just recommend using it where it's useful and not everywhere, and just kind of like use it more in sort of special case situations. But yeah, if the performance constraints, you're doing something offline, or you're doing it on high-end PC hardware that's not like running on a PlayStation or something like that, then you've got more compute power to utilize. You could probably use it in a lot more places, a lot more aggressively. So yeah, I guess it's as it always is in game development or real-time rendering in general. Just test, like try things, see how see what your frame rate is, to do basic profiling, just do profile GPU, see if the nanite time is really expensive, and if it's running well for you, then you're good.
All right, fantastic. All right, well, with that, I think that's probably a good place to call it there for today. Again, if there were any questions that you all had that are watching that we didn't get a chance to get to, we will answer them. We'll just collect all of them that we had, and we'll probably, what I'll end up doing is follow up with a forum post that'll have some answers just in one big ol' conglomeration for all of you to check out. But with that, I want to take a second to thank all of the guests for coming on today and chatting about the features and going over this overview with us. Of course, as is inherent by the title of it, it is an overview. There is tons of stuff that came out in 5.4, so make sure that you check out the release notes to really dig into all the details of what happened. But thank you all for taking the time to be here with us today and to chat with us and answer some questions. All right. Well, with that, the little wrap up for everyone watching. Of course, thank you for being here and for interacting and asking questions. The show wouldn't be what it is without you and you being here to watch. So thank you also for taking the time to be here with us. If you missed any part of the stream, there was tons of really good information in it. No worries. We post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channel at Unreal Engine. You can also keep up with all the latest news and all that good stuff on both the Epic developer community as well as our socials at Unreal Engine. So make sure you keep up with stuff there. And tomorrow we have another Project Titan live stream. Project Titan is the massive, I think now over 4,000 people developer project where everybody is just making one giant world all together. It's absolute chaos and a lot of fun. If you'd like to see how progress is going on that, you can check it out tomorrow at 11 a.m. EDT. But with that, that's everything. I managed to do that without losing my breath. So thank you all once again for coming to be here today, and we'll see all the rest of y'all later. Bye, everybody.
Bye.
Now, bye.
Thank you.